Okay, so welcome back to the Algebra 1 show. It's a little less entertaining on the video than in person. We're missing all the traditional Algebra 1, 8th grade kind of stories of trampolines and cats and dentists and all other sorts of things that you guys end up talking about on a daily basis from the 8th grade world. But I'll do what I can, at least for the algebra part. You guys will have to get in touch with each other for all the other miscellaneous sort of crazy things that you guys do like to talk about, which are sometimes quite entertaining to me as well, I must say. But anyway, back we are on the Algebra 1 process of we're trying to work toward being able to add and subtract fractions. So in the last lesson, we figured out how to find a common denominator, which involved looking at the bottoms, factoring, and picking everything the most we could ever find it. I advertised in that video that in the next session we'd be worried about changing the tops. So today I have tops on my fractions because those tops are going to have to change. We need to build on this skill into the next lesson because next time after we get these tops changed, we're going to then actually go through the process of adding and subtracting them, but we're kind of building it up into baby steps. That's what makes Algebra 1 Algebra 1. Someday in Algebra 2 you'll probably do this, and instead of a 3-day lesson it'll be like half of a lesson or one lesson at most as a reminder someday. But if we saw these, back to an easy example from our life in 7th grade in elementary school, the first thing you have to do is figure out a bottom, like last time, what the 4 and 6 go into. They go into 12. And then our 7th grade book used to call this the name changer machine, if you were around for that. The concept is now, whatever we multiplied on the bottom, we'll multiply the same number on the top. So this bottom, turning into 12, is multiplied by 3. So we go to the top where we happen to have another 3 by coincidence, but that's just luck. Since we multiply the bottom by 3, we'll multiply the top by 3, and now that's 9. For the 6, we're going to multiply the bottom by a new number. The 6 would multiply by 2 to make 12. So the top multiplies by 2. And that's now 10. And if you want to write that way, that's fine. I'm going to give you a shortcut way to write these answers is, since the bottoms are all going to be the same, and some of the bottoms are going to get a little bit big as we go, when we get to the far right corner. There's some bigger stuff over there. If you're not feeling like writing the bottoms twice right now, I'm not going to make you. You can write the bottom once, and then just write the 2 separate tops on the same bottom like that. If you want to do that, I'm fine with that. Save yourself a little bit of pencil lead or ink, save me a little chalk. So for something like this, they're both going to have the same bottom. Take everything the most you see it. We're looking at an x, so we have to take that. We see a y squared, we have to take that. Everything we see, we have to take. Then we look and think, what was this fraction missing? This fraction was missing the y squared. Since a y squared is joining the bottom, the 4 has to have a y squared join the top. And then move over to the 5 and go through the same process. What was this missing before? This did not have the x. An x multiplied onto the bottom. So if an x jumps on the bottom, the x has to join the 5 up on top. So we have 2 different fractions. If you're more comfortable writing 2 completely different fractions with the same bottom, if you'd rather write your answer that way, same bottom twice, feel free. That's absolutely fine. But I'm telling you, I'm absolutely fine with this too. Whatever. For this, again, back to yesterday's lesson, looking at the bottoms first, the key word yesterday was most. The most x's I can see in these bottoms is x squared. The most y's I can see is y cubed. So that's how I'm going to establish the bottom for 2 different tops. Then we have to figure out what new stuff just joined onto the bottom. This was short a y squared. The x's are good, but the y's were short a couple of y's. So the 6 needs to get a couple of y's multiplied in there. This, the y's were good, but this was short an x. We want x squared, we only had a single x, so the 7 needs another x, and we're good. That's the basic scheme of most of these. We are going to have to start to factor in a minute. If you think you've got it, maybe pause the video and try this one for a second and see if you've got it. If we were live and in person, that's what I would do. I'd pause and just see if you can do it. But for this, we go 24 for the numbers. 4 and 6 go into 24. My most x's I see is cubed. The most y's I see is squared. And then I think about multiplying. 4 to get to 24 is times 6. So 5 times 6 is 30. This has 2 more x's than that did. So this needs 2 more x's than it had, up to 3. But the y's were good. We already had the y squared handled. And then move to the other fraction. This 6 multiplied by 4, so 7 times 4. The x's were good, but we picked up a new y. So on top, pick up another y, and we're y squared. Starting on this 5th one and filling the rest of the board, we're going to have to factor first. So I'm in a factoring kind of mood right now. So if you want to factor one problem at a time in the homework, you can. But if you want to start off your homework and just do factor mania, go ahead. I'm about to do factor mania. So I'm looking at the bottom. 4 GCF leaves x plus 1. 6 GCF leaves x plus 1. And those are no longer of meaning to us. GCF of 6, x minus 2. GCF of x, x minus 3. And those just lost all meaning. GCF of 5, x plus 1. This, no GCF, we're going to unfoil that, xx, plus plus, 3, 1, out. This, there's no way to factor it. If you like invisible parentheses, make them visible. This is a difference of squares. We've had that a number of times. If you're having trouble with factoring, email me and we'll work it out. This, x plus 2, x plus 3. For this, x plus 6, x plus 2. Out. X plus 3 twice, or if you prefer to write that as a square, feel free. I'm going to make that be visible instead of invisible parentheses. That's gone. X plus 4 twice, or write it like a square if you'd rather. X plus 4, x plus 3. In a final answer setting, we want to write these as squares. But while we're working them out, it doesn't really matter when you're in your work mode how you write them. This is x plus 2, x plus 3. This is x plus 5, x plus 2. So factor mania. Any problem that has adding or subtracting on the bottom, you have to factor if you can to help you do this common denominator choice just like we did yesterday. Yesterday we were factoring, and then we were picking everything the most that we could find it. So back to this. Okay, with numbers, 4 and 6 is still going to do 12 as it had been. And then other things we see, the only other thing I see is x plus 1. I don't do any power on that because I never saw it more than once per fraction. It was once in this fraction, it was once in that fraction, so all I need is one of those. And then we look at what changes we made. If you change the bottom, you have to change the top. So the only change here is 4 turned into 12 by multiplying 3. So the top multiplies 3, and that's a 9. On the bottom, the 6 turned into 12, multiply 2. So 5 times 2. And that's actually almost a twin of the number 1 problem we came in on. We had 9, 10, 12. The numbers did the same thing. The only difference was this x plus 1 factor was in the mix. For the next one, 6 and 8 would make 24. I see an x minus 2, and I see an x minus 3. And I just have to take them both. Two groups of parentheses, they're both going to come. And now you might see the advantage on y. I don't really feel like writing that twice. It's the same bottom for everything. So I'm just going to now write some stuff for the tops. For 6 to be 24, that's times 4. So 5 is a 20. But we also picked up on the bottom, that first fraction didn't have an x minus 3. The bottom gained that, so does the top. 8 to make 24 is a 3. 6 times 3 is 18. And the other thing the bottom had been short is an x minus 2. Up a step. This problem on the bottom, I have a 5. I have an x plus 1. And I have an x plus 3. So I need to take all of that stuff. Anything I see anywhere, I have to take it because it's about the most. What do you see the most? It wasn't over here, but x plus 3 was over here. The most I see it is when I see it, so I take it. For this first one, 5 is good. X plus 1 is good. They were already there. X plus 3 is new. So 7 needs x plus 3. For this, both of the parentheses, both of the factors groups are good. The only thing new is 5. So multiply 6 by 5, and that's 30. For this one, x minus 3 and 3 minus x are kind of sort of the same. Okay, yesterday I told you just act like they're the same for a day for yesterday's purposes. So for right now, just pick one. I'm going to pick 3 minus x. No real reason, I just have to pick one, so I just randomly grabbed one. 3 plus x is different, so I have to take that. And yesterday we didn't care about them being a little bit different. Today we do. Today, when this is changing into this, the only thing that's really different about these when we subtract in opposite order would be the sign. So the 4 gains a negative to handle that sign switch, and also has a new friend. This bottom did not have the adding group, so we can put that on it. For the second fraction, the greatest thing that can happen on these is the bottom already was what we wanted. And so if you don't have to change the bottom, you don't have to change the top either. The 6 can just stay a 6. That's handy. For this next one, if we look around, what different things do we see? An x plus 2 is around. An x plus 3 is around. An x plus 6 is around. We'll take them all. Who 5 didn't have was the x plus 6. 2 of these were on the bottom. We just need 5 to take the new one. And 6 also needs to take a new one, which would be x plus 3. If you have the hang of this, just pause me and just keep rolling. This one, I have x plus 3 twice here. So in my final answer world, I am going to write this as a square because that's the better way to write it in final answer world. This looks simpler than that because it is. The bottom didn't really change though. This was good. We kept it. So keep the 6. 7 was part of an incomplete world. This didn't have 2 of them on the bottom. So to make the bottom right, the top needs to also gain an extra x plus 3. For this one, I have an x plus 4, but it needs to be squared because there's 2 of them. The most I ever see at one time was 2 of them here. And there's also on the loose an x plus 3. 7's fraction did not have the x plus 3. So that's who 7 needs to be with. 8's fraction only had 1 of these, not 2, so it needs another one. And then we're good. For this last one, there's an x plus 2, an x plus 3, an x plus 5. This did not have the x plus 5. When we go to throw that on the top, there's invisible parentheses that I'm going to make visible for these. x plus 1 needs to take on x plus 5. The x plus 3, it had the 2 and 5 things, but it did not have the other x plus 3 factor, so that's now a square. That's what we have going on today. Let me look at the homework page really quickly. We're still on the same page, 331. You're working from 15 to 20, and then 27 to 32. As a preview of tomorrow, what would happen tomorrow is we repeat this whole process, but instead of a comma, there'd be a plus or a minus. And so an answer from this would become something like 19 with the same volume, which shouldn't be a really big deal to us tomorrow to just add on that one little thing. Some of it though, it's a little more than that. Let's say I made this into a plus. To add these, you'd have to do a distribute. You'd have to do a distribute again. You'd have to combine like terms. Something like this last one that was kind of big. If that weren't a comma, but that were a plus, you'd have to FOIL it. You'd have to FOIL that. You'd have to combine like terms. But that's our only little add-on tomorrow will be basically repeat this whole thing, but if you see a plus in the middle, like add them, combine like terms. See you next time.